In this section, we're going to cover right triangle trig. So we can kind of go back to what we learned about back in earlier sections in chapter 5 about the relationships between sine and the y value of the coordinate point, so the vertical, and then the r value, so the radius of the circle. So if I took a triangle and imposed that onto the unit circle, we can see that now that hypotenuse is the radius value. This ends up being our x value, or our horizontal distance, and this ends up being the vertical distance. Take that whole concept and actually create a new way of looking at sine and cosine and periodic functions in terms of a right triangle trig. So looking at it from that route, we would call this, if this was our angle, if the angle on the triangle was here, this is known as the adjacent side. It's the side that's next to it, that's not the hypotenuse. And then the side that's opposite it is called the opposite side. So for example, if I had a triangle here, and instead my angle was here, this would be the opposite side, because this is opposite it. This would be the adjacent, because that's the side that's next to it. That's not the hypotenuse, and the hypotenuse is always that diagonal side. So another way that we can define sine, cosine, tangent, so on and so forth, is by using this concept of right triangle trig. So sine, we always said, was that vertical distance, which is now, if we're talking about this triangle, the opposite over the radius of the circle, which now that radius is known as the hypotenuse. And then this would be that, the cosecant is going to be that flipped. Cosine is going to be, so cosine is normally the horizontal distance, where in this case that's going to be the adjacent side, over r, which is the hypotenuse. So this is going to be the reciprocal of that. And then tangent is normally the y value, which is the opposite, over the x value, which is the adjacent. So again, cotangent is going to be the reciprocal of that. So the name of the side that's not labeled, so if this was our angle, there's your hypotenuse, this is the opposite side, this is known as the adjacent side, because again, it's touching it, the angle, but it's not the hypotenuse. So we can figure out the value of that side. Again, remember a squared plus b squared equals c squared for the value of a right triangle. So we know our, I'm just going to call this missing side a. So we don't know a, but we do know the b squared. So b is going to be that other leg, and that equals 10 squared. So we get a squared plus 49 equals 100. So a squared equals 51, so a equals the square root of 51. And now we can use right triangle trig. You can go back and use our x over r and all of that, but we can use right triangle trig to find the values of the other 6 trig functions. So this is a lot to kind of handle, memorizing all of those, and I'm going to show you guys a mnemonic device that really helps. So if you think about this, it's SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, TOA, tangent is opposite over adjacent. So SOHCAHTOA. So if we had to find sine, that's going to be the opposite side over the hypotenuse. So if here's our angle, the opposite is 7 and the hypotenuse is 10. If we were trying to find the cosine, so cosine is adjacent over hypotenuse. So the adjacent we just found was the square root of 51 over the hypotenuse, which is 10. And then the tangent, so tangent is opposite over adjacent, so it's going to be 7 over root 51. And then I need to get that common, or that rationalize the denominator, so I get 7 root 51 over 51. And I'll let you kind of go through and figure out the rest of those guys. Okay, so now let's find the value of trig functions of an acute. Let's continue with that. So in a previous section, we stated that if two angles are complementary, the sine of one angle is the cosine of the other and vice versa. These angles we define as being co-function, and they're indicated by the co-prefix. So for example, cosine and sine, cosecant and secant, cotangent and tangent. So if we were asked to find the following values, so Complementary, just so you guys know, means that two angles are complementary if they add up to, so if the sum of them is 90 degrees, or pi over 2 if we're talking about it in terms of radians. So if we were talking about this, we would say we could find the value of the sine of 35 degrees. So the value of the, well, we couldn't find it, but we know we can find an equivalent thing. So the sine of 35 degrees is going to be the same thing as the cosine of the complementary angle of that. So again, the complementary angle means that when I take this and I add it to 35, I'm going to get 90. So to see what's missing, take 90, subtract that 35 degrees, and we get 55 degrees. And again, 55 plus 35 equals 90. So these are equivalent angles. You will get the same exact answers. Just like if you looked at the sine of 30 degrees, which is 1/2, is equivalent to the cosine of 90 minus 30, which is 60 degrees. And both of those are 1/2. Okay, so if we wanted to find the secant of pi over 2, so that's going to be equal to its cofunction, which is the cosecant of, again, these have to add up to 90, so let's see what we've already taken. So we start with pi over 2. We're going to subtract pi over 12 from that. And when we do that, we get cosecant of 5 pi over 12. Okay, so those are equivalent angles. The tangent of pi over 3, so that's going to be equal to its cofunction, which is cotangent of pi over 2 minus pi over 3 to see what's left over, so that these two angles will add up to 90 degrees, or pi over 2, and we get pi over 6. So knowing this, we can actually solve a formula like this. So right now, cosine squared of 25 degrees plus cosine squared of 65 degrees, these aren't special angles, so I have no way of actually figuring out this exact value if I don't have a calculator. But what I can do is I know I can rewrite, so the second one as its cofunction, which is going to be the sine function. So this is going to be, let's see, so 65 degrees, so 90 minus 65 ends up giving me 25 degrees. Sweet. So again, if I take 25 plus 65, I get 90, so that's why I could replace those with sines and cosines. And we know that formula, sine squared plus cosine squared equals 1. So since I've got the same angle, now I can just say that I know that that's 1